Okay, welcome back to the channel. This is the Prokon Geek, and in today's video we're now moving on to doing the first floor layouts of our double story building. So essentially what we'll be doing is placing the beams and also defining our slab, which we do after we do a preliminary design. So this will also be an introduction to the preliminary design of beams and slabs as we try to fit them in for our double story building. So without wasting too much time, let's just get into it. Alright, so if you remember from the previous video that we did, what we did is we came up with the foundation layout, and then we also did the ground floor layout. And as we were doing the ground floor layout, what we did is we just copied the cleaned frame from the foundation layout to the side, so that we have a clean shell that we start using when we come to the first floor layout. So the first thing that we're definitely going to do is we're also just going to copy this to the side, so that when we come to doing our eaves floor layout as well, we have a clean drawing to start off from. Okay. So the next thing that you want to do now that you want to, this is now the first floor layout, you just want to change the name now. You want to change the name to, this is definitely the first floor layout, so that you don't confuse yourself. The scale is still 1 in 100, so you're good to go. Now the other thing that you want to do now, sometimes you can remain with the walls, or sometimes you have to remove them, but for clarity's sake, what I'm going to do is just remove all the red lines, just remove all the red. What I have to do is just, let me just quick select, and let's just say what we want to do. We want to remove the lines if their color equals red, so you're going to select all those lines, and wow, it seems it did not remove them. I don't know what happened, but let's just remove them manually, so it's easier that way. And the other thing that you want to do, after you remove all the red lines, the next thing you want to do is turn your hatch into a solid hatch, and then you want to choose the color to, let's just choose a new color. Select color. I like to prefer color 9, so I think that's okay. Then the next thing that you want to do is just MA and just start changing everything. We'll also change the grid lines, don't worry about that. Change everything to color 9. So the reason why we're changing it to a solid hatch is because a solid hatch represents anything that is below what you're representing. So to change back our grid lines, what we're gonna do is do that and do this. And to make our things more visible, let's just change the line scale to LTS. I'm just gonna make it we just make it 500. Yes, as you can see now, the lines are much visible. The differences in the lines is now clear to see. So after doing this, the next thing that you want to do is, obviously, you just want to make sure that the display order is sent to back, display order sent to back, display order sent to back. So display order sent to back as well. Display order, just make sure it's at the back. Display order everything, just make sure the hatch is send it to the back. Then the hatch as well, send it to back. Then the hatch this side, just click on the hatch, display order, send it to back. And alright, we clicked on the wrong thing, so click on the hatch, let's send it to back. Click on the hatch again, then display, send it to back. The next thing now, what we want to do is we need to consider the stiffness of our structure. So to do that, now we want to start placing the beams and the slabs. So some of the things you want to do is obviously checking from the ground floor, the layouts, the architectural layouts. You have a slab that's sitting on top of the walls, but in our case we made our structure framed as we provided columns, so it's going to be connected to beams and columns supporting the slab. We don't have a flat slab, mind you. So what we have to do now is provide the beams which will support, but in essence we have one entire slab, so let's just define that slab. So go back to your drawing and just click on rectangle. Make sure that now you have concrete above. Okay, concrete above plan. So what you're going to do is you're just going to create a polyline all the way from there to where you have your slab. So as you can see now, this line represents the edge of the slab, and your slab spans from grid line 1A at the edge of this column where my cursor is. Then it spans all the way, comes down to 3A at the edge of this column, goes all the way again to this, which is grid line 3E, edge of the column, all the way again to grid 1E, edge of the column. So all of this, let's now put a line just to represent the span of the slab all the way coming to this is a slab, and let's just change this to symbols. So we're changing it to symbols and we're good to go. And also we need to annotate and represent that it is definitely a slab. So what we're going to do is now just paste this there and then rotate it nicely, so that let's turn off F8 for a while. Alright, so I think we also need to turn off F3 so that it doesn't snap to unwanted places. I think this is okay. Let's just move it so it doesn't interact with the hatch. And in this case now, this is not going to be a 150mm thick slab because it's different. This time we need to size the slab. The ground floor slab, why we just took 150, that was the minimum ground slab, and also because this area is just going to be a classroom without too many loads that are going to be on it, so we just decided to do a 150mm thick slab. But now what we have to do is now size the slab, and to do that we now have to do a preliminary calculation design to size the slab. So what I'm just going to do is change this to remove the thickness, and this is just going to be RC slab because the reinforcement, that is what we're going to have to calculate. So let's just push this a little bit over there, and now let's do the preliminary design of the depth of this slab. Alright, so just a minute before we actually do the preliminary calculation for the depth of the slab, the first thing we also have to do is place our beams. The reason why is because we have placed the slab, but what we did is we essentially just placed the entire bay of the slab, but we don't really know, we haven't really defined our panels, and our panels are defined wherever we have supports for the slab. So in our case, we need to define the panels for the slab, because the reason, if you have too long, if your panels are really long, the depth of the required slab will be too much. But if the beams will help you make smaller panels, so wherever your slab is going to be supported, then that's where your panels will be created. So in this case, I'm going to create panels which are in this direction are going to be 5 meters long, and in this direction I think 6 meters is okay. If it goes beyond 6, that's when you really start having problems. And in this case, we're going to have a 2-meter panel, 2x5 panel. So to do that, now let's place our beams. So to place our beams, what we have to do is let's just create Prokon Geek beams. So what I'm going to do is I'm going to create beams which are just as thick as a walls. So right here we're going to have a beam. So the edge of the concrete where you have this one is going to serve as also as the edge of the beam. So in our case right now, you may not be able to see the green line, but I think it's there. But you definitely see it once we print out. As you can see on this layout, it's clearly defined. This dashed line represents the beams. So this is it. This is how you'll be doing it. So to do that, let's go back to AutoCAD. I'm just going to continue placing these beams. So in this case, we're just going to grab from no. Let's just do this, and then we grab there. That is okay. Then we were going to continue with this line all the way to there, and then just repeat the line as we continue placing our beams. This time I can just go all the way there. It's not a problem. Then we're going to place the beam line there as well. Then we're going to repeat out, and then we can just go all the way to there, so that the line shows out throughout the entire structure. And then we're also going to place our beam wherever we have wherever we have our walls, we're going to place a beam above it, so that our slab is, we have a framed structure, because what we want is a framed structure. We don't want our slab being supported on the walls. We want beams to carry our slab, so that in case they want to remove the walls and just remain made with partitions or anything, even the client changes that they don't want 230 load bearing walls anymore, the structure is still integral. So sometimes you might find that you want to remove the wall that's in the middle and just have one large room. So if we have our slab being supported by the wall and we remove the wall, then we're going to cause catastrophe. There's going to be a disaster. That is not going to work. But the place when we have a beam carrying our slab right above the wall, you can remove the wall, and your slab will still be integral. It will be supported nicely. So the other thing is we also want to put 230 beams. I'm just going to make them 230 wide so that they blend in with the walls. So what I'm going to do is I'm going to offset this grid line by 115 either side. Same applies to, actually we don't have to do that. Let's just do it for this one, and then we'll just copy since it's quite symmetrical. The other thing is you now want to trim. So let's trim those unnecessary lines. This should be trim. Right, this is what I'm just going to do. Trim, left click, remove this line, Move this line. That's should have just used the outer line. Another thing that you want to do as well, just remove this, and remove this, and probably just remove this and remove this. Then the rest of this you will just have to delete. Right, so let's just select that, and just erase. So once you've done this, the other thing now you want to do is make sure that these lines conform to the beams. So change the line works. In your case, if you don't have a template, all you have to do is just click the green, make them green and make them dashed. Once you're done, the next thing that you want to do is copy this. So we're going to copy it from the center of this, and we're going to throw it to the center snapping point by this. So what we have essentially done is we now have a beam there and we have a beam there. Then we also don't want to forget this area as well. We want to create a beam. So yes, we have the beams layer selected, so just create another huge beam. It's going to be a continuous beam supported at the columns, as you can see. So we're going to have a continuous beam for the balcony, which will be joining the columns, and this will also help tie in the building, provide structural this will also help, in providing the bracing for the building. So remember, whenever you're doing your buildings, you want to provide the ties, so this will provide the ties. And also, I'd forgotten, I want my beams to extend all the way to the side as well. So I'm just gonna, let me just copy this line so that our beams extend all the way to the right. So I think I'm snapping to the wrong points, so the best thing for me to do is just let me click this line, click extend, and there we go, there we go, there we go, there we go. And then obviously you want to trim so that they don't appear. So select the columns, then remove the lines. That is good to go. Then you also want to come trim, select the column, then remove these lines. Move the line, then make sure the edge is in its proper position. Wherever you have the edge overflowing into your column, make sure that you don't have that, because it will mess up with your drawing at the end. So also we want to provide beams over there, so just copy this and copy it from the center, and then you place it there as well. So now what you've seen, you have a beam, so you have a beam on this wall, beam on top of this wall, beam on top of this wall. So this is just essentially one beam, so it's going to be on top of this wall for this section, and then it's going to go all the way to the other column for 2 meters. Same applies throughout the entire balcony. And also at the end of the balcony you have a tie-in beam. So essentially these external beams will be ties, tying the structure together. Then also these are external ties. Then these internal beams will be internal ties, tying the structure together, so just to provide the integrity of the structure. So now we have placed our beams. The next thing that we want to do, obviously, now let's just preliminary just take the next thing, we want to size the beams. Now what size for these beams? So right now let's just put beam, I'll put it first floor beam 0. This one will be 4. Yes, 4. So I'll start with 1, 2, 3, then 4, 5, 6, going like that. So yeah, let's just copy this to the side as well, and then rotate it 90. Okay, this is rotated by 180 now. Right, so then move it. What we're gonna do is we're gonna have one. So we're gonna continue this now. I think let's now size our beam so that we see what the best way or the best size for those beams is. So let's do the preliminary design. Alright, so to do the preliminary design, we're gonna start off with the slab. So to do the preliminary design for the slab, we need to identify the largest panel that we have on our structure. So in this case, after placing our beams, the largest panel that we have is going to be, let me just put a hatch to show you what the largest panel now is. So it's taking too long, but now there is, you can see this is the largest panel that we now have. Let's just make it that, and I think it's still solidified, so let's just, so that you can easily see which panel I'm talking about. So the panel that I just shaded right now, that is the largest panel that we now have, because all of these are now, they're the 1, 2, and 3, they're all symmetrical, they're all identical to this panel that I just shaded. And this panel is 5,000 by 6,000. So the short span, this is definitely a two-way span slab, because the largest size 6, is not 2 times greater than 5, so it's a two-way span slab. So to size the initial depth, what we're going to do is I have a MathCAD sheet which I use, which is a cool software. If you want you can actually just download this and then install it for yourself. So calculating the depth of the beam, so slab 1, so you provide the span of the beam. Oh no, sorry, this is for the beam depth, so you want to do for the slab depth. So yes, this is the sheet for the slab depth. So when calculating the depth of the slab, just remember you need to provide, first thing you do, you need to provide the short span of the slab. In our case, it's definitely 5,000 millimeters, so it's okay. Then provide span over depth limit factor. So to provide the span over depth limit factor, what you need to do is you need to refer to the code that you're going to be using, right? So let me check where is my book. I don't think I still have it, but when we do using Greg Parrot, what I think I'll just put a picture for you so that you can see the span. When you're doing a preliminary design, you need to do what we call span over depth limit factor. So this helps you in making sure that your deflection doesn't go beyond 20 millimeters, especially when you're using South African Board of Standards or South African National Codes. But it's the same, it was adopted from the British standards, which is BS. So in our case, the span limit factor that we have is going to be X, is going to be equal to 29. This is based on using one end that is continuous, a two-way spanning slab condition to be conservative given our setup. So you choose you look at your setup, right? And then once you look at your setup, right, one end of this is definitely continuous, but then we have one of the end terminating at the column, so we'll just say one end is continuous and the slab is two-way. It's spanning two ways, because this will be the continuous end where we have, and also A2, but A1 is not continuous, it's restrained. So that is why we chose one end continuous, but it's a two-way spanning slab, so the limit factor is 29. Then the effective depth of the slab, right, D, will be given by Lx, which is your short span, over X. Therefore, this automatically calculates D for us. If you say 5,000 divided by 29, you're going to get 0.172 meters. Let me just put it in millimeters so we can have, all right, so that's, sorry about that, 172.414 millimeters. Then the overall depth of the slab, what you do is, now this is the effective depth and the overall depth of the slab are different. The effective depth is the distance to the center of the steel, but the overall depth is from the top of the slab to the soffit of the slab. So we are just going to add 30 millimeters. That's a rule of thumb if you're using SABS or BS. And so what you're going to do is D plus 30, and it's going to give you H is equals to 202 millimeters. Yes, let me just change it to millimeters so you really, it's 202 millimeters. But remember, H is always rounded off to the nearest tenth. So if you're rounding off to the nearest tenth, it becomes 200 millimeters. So what you do after doing that preliminary design, all you have to do now is come back there, right? And you're going to say 200 millimeter thick RC slab. Right, and you're good. That's what you would do. Reinforced, if you want reinforced as per structural steel drawings, right? Because in the end, what we're going to do is we're going to provide structural steel drawings, and those are the ones we're going to use. Those are the ones where the contractor will be taking the reinforcement for this slab from. So what you just want to is you want to give them that this is a 200 millimeter thick reinforced concrete slab, reinforced as per structural steel drawings. All right, so once you do that, you're good to go. You have sized our slab, and in our case, if you check, it's 200 millimeter thick. So I think I just copied this, so don't worry about that. But you want to say reinforced as per structural steel drawings. Then the next thing that you want to do is you want to resize your beams. So to size your beams, another MathCAD sheet, you want to provide the span of the beam. So we look at the west or the longest beam that we have. So the longest span of beam that we have, so the span is always between the supports. In this case, the longest span between any supports is going to be 6 meters. So that is the worst case scenario. So that is what we're going to use. So we're going to have 6,000 meters. Then provide span over depth limit factor. I used one end continuous condition, C SANS based Greg Parrot book, to be conservative given our setup, so you refer to your codes. So in this case, we're using X is equal to 24 as a span over depth limit factor. So By span over depth, it just means L over D is equals to X. So to make D is subject to the formula, just do your mathematics, you know what it is. So just put X to the other side, D to the other side, so D becomes L over X. Therefore, the effective depth of your beam will be 250 millimeters, and the overall depth of the beam is now, in this case for beams, you add 50 millimeters, so H is equals to 50, and then H is definitely going to be equal to 0.3 meters or 300 millimeters. So to do that now, the only thing that you have to do is come back to your drawing. We're going to do it with this one. So you're going to say this is going to be a 230 by 300 deep, but this is going to be a downstand beam. A downstand beam is essentially a flanged beam, because when you're doing let me just put a picture up for you so that you see what a flanged beam is. So when you're doing a slab or frame structure, you want to cast your members monolithically. So you want to cast the beam monolithic with the slab. So part of the slab now provides the depth of your beam when it's flanged, whether it's a T beam or it's an L beam. So if it's going to be in the exteriors, it's going to be an L beam. If it's going to be in the middle, it's going to be a T beam. So what we term those beams, we term them downstand beam. So the D/S stands for downstand beam. So this beam is going to span all the way from A to E across it's going to be along grid line 1, then it's going to span from A to E with having supports at A, B, C, D and E. So as you can see, we have just sized our beams. So what we did is we designed for the worst case scenario, right? So 6,000 millimeters is the best, and the reason why we just want to make them uniform, it's easier on the contractor and anyone who's going to be placing these beams on the ground, so it's easier to make them. So once you've done this, so all you now know is that all of our beams are going to be 230 by 300 deep downstand beams. So the next thing that you have to do is now just copy this and then annotate all the rest of the beams, so that in the end of the video, what you have is something like this, where you have or you can just skip the width of the beam as well. Just say it's going to be a 300 deep downstand RC beam. As you can see, we have a 300 deep downstand reinforced concrete beam, FF beam 1, this beam 2, then this is beam 3, then this is going to be beam 4, this is beam 5, and this is beam 6. So since we have symmetry on our structure, this is going to be beam 5 and beam 4 as well, because they have the same setup. So that is it when you're doing your first floor layout. So the rest of it, I don't want to make the video too long. I've given you the essentials of this. The rest, as you can see, is just now copying the annotations and placing them where you need them, and also just removing this because it's no longer necessary. So this is it for today. Thank you very much for tuning in. And next time that we're going to do is either we're going to see the eaves layout or the section, and then we rush it through it so that we can now do the takedowns and start keying it into Prokon. So thank you very much.